Assalamualaikum warahmatullahi wabarakatuh. We are from RCBCS 1432G. For calculus 1, we are going to present about applications of differentiation.
Before we start our presentation, we would like to introduce ourselves first. So my name is Nurzakirah binti Zainurin and my metric number is 2022878248.
Hi, my name is salsabila nuraisyah. My matrix number is 2022848988.
Hi, my name is khairunnajah binti fauzi and my matrix number is 2022849696. Hi, my name is qaisara aniqah binti rahman and my matrix number is 2022872106.
Before we go in deep into our example that we provided, I would like to explain about related rates. Related rates is used when there are two or more variables change at the same time. Okay, so if we have the relation between this variable, we can also know how fast the first variable changed and also how fast the second variable changed. And it's also applicable if there are more variables there. Okay, now let's move on to the simple example. Let's say we have conical water container and then we pour water in it. So, if we look at the volume of cone formula, if the volume of water increase, it will increase the radius and also the height of the water. Now, if we find this kind of question, how we want to solve it? We solve it by using chain rule. Okay, let's see. The question asks how fast the volume increase. We will extract this question to dV over dt. And then, if apply the chain rule, we will separate this formula to dV over something multiply with something over dt. And this something, we will refer to the question whether we need to calculate it or it's already stated in the question. Now, let's move on to the example.
So, for the example of question, we have here orange juice is poured into a conical container at a rate of 12 cm³ per second. The radius of the container is given by 5 cm with 15 cm height. We want to find how fast is the radius changing at an instant when the height of the orange juice is 8 cm. First step, we have to extract the information from the question. We have here R equals to 5 cm, height equals to 15 cm, and also we know that the rate of change is dV over dt equals to 12 cm³ per second. And then, the question wants us to find how fast is the radius changing when orange juice reach at 8 cm. We have to do this equation. dr over dt equals to dV over dt multiplies by dr over dV. But we have a problem here where dr, we don't know what dr is. But we know that the basic formula of volume for cone is V equals to 1 over 3 pi r squared h. So, we have to substitute h into r to find rate of change for radius.
Moving on to a more detailed explanation. So, as Bella just said, the main objective of this question is that we want to find how fast is the radius changing at an instant when the height of the orange juice is 8 cm. So, the formula that we have is dr over dt equals to dr over dV multiplied with dV over dt. So, as we all know, the question already gave us dV over dt, which is 12 cm³ per second. So now we have to find dr over dV to apply into the equation. So first of all, using the basic cone's volume formula, we have volume equals to 1 over 3 pi r squared h. So as you can see, we want dr over dV. But in this equation, we have three variables which are v, r, and h. So as you can see, there's only R and V here, but here we have H. So that's why we are going to use the information that is given, which is R equal to 5 and H h equal to 15 so that we can substitute into the equation here. So, as you all know, we have h over r equals to 15 over 5, and if you simplify it, you have h equal to 15r over 5, and if you simplify it further, you have h equals to 3r and r equals to 1 over 3h. Okay, moving back to this equation here, we don't want h, we only want r. So as you all know, h equals to 3r, which we are going to substitute into here. So if you simplify it, you got 1 over 3 by 3r cubed. So to simplify it further, you have to multiply 1 over 3 with 3 here, and then you will get pi r cubed. Okay, moving on to the next step, we already have the volume equals to pi r cubed. So to find dr over dv, first we have to differentiate, but we use dv over dr because the equation equals to r, so dr is inside the equation, which means it has to be under dv. So it's dv over dr. So we want dr over dv, not dv over dr. So we have to change the position, which equals to 1 over 3 pi r square, because this is actually 3 pi r square over 1. So when we change the position, we have 1 over 3 pi r square. So now, using the chain rule here that we applied in the beginning, as we know, dr over dv is 1 over 3 pi r square, and dv over dv equals to 12. But the problem here is, the question wants to know how fast the radius is changing when the height equals to 8. So from r here, as we already find in the previous solution, we have r equals to 1 over 3h. So we just substitute that here, which is the h that the question wants is 8. So 1 over 3, we have to multiply with 8, and then we have 8 over 3. But this is simply just because the question asks so. But if the question wants 5, then you can put in 5. But now the question wants when the height is 8. So we put in 8, and then we get 8 over 3. And then we can finally use your calculator and then to get the final answer, which is 0.179 cm per second. So, before we end our presentation, we can summarize that we had a look into the meaning of related rates, how to use the chain rule, and also the example question and the solution. Therefore, it is important for us to identify the right formula and then to use the information given correctly. So, we can substitute it into the chain rule, and then we will get the right answer. And also, don't be careless.
That's all from us. Thank you.
Bye-bye.